Hi guys, welcome back. So we're following on with the exercise for the tangent function. Okay, so what we need to do is we need to solve each of the following where x is an element of negative pi to pi. Okay, so think about that as what we're thinking about. Okay, we're going from pi to negative pi. Okay, so we're finding it within this range. Okay, so what we need to do is we need to find tan x of -1. Okay, so what we've got is we're going to go x is equal to inverse tan of -1. Okay, so what we do is when we do that, we refer to our little handout that we have. I've given everyone. Okay, so if you look at the tan column in the final column, where tan is equal to 1 is actually when it's actually pi on 4 or 45 degrees. Okay, so that's where we find our variance. Okay, but that first value is obviously all those values within that first quadrant. Okay, so as we're going around from 0 to pi. Okay, as we go from 0 to pi, we've obviously got our first value there at pi on 4. Okay, but remember that our domain is between -pi and pi. So if we go to negative pi, we go back the other way. Okay, we're going to find the location of where, remember the tan is a gradient function, okay, where the gradients are the same. And that is actually -3 pi on 4. Okay, so that becomes -3 pi on 4. And those are our two values. So if we had our function over here where the value is -1, okay, we'd have it cross between -3 pi on 4 and pi on 4. Okay, so those locations right there as a sort of example. Okay, so there are our first two values. So it's nice and easy. Okay, we haven't had to change the period at all. Okay, we haven't had to do much manipulation. Okay, we might get a little bit with B and C. Okay, so what we're going to do is we get tan 2 of x is equal to square root 3. And what you're going to notice with the 2 of x, remember that's been dilated from the y-axis. Okay, and we're actually going to get twice as many values. So what I'm expecting is, rather than getting two answers that we got here, I'm expecting us to get 4. Okay, there's a couple of things that we need to do. Okay, first thing we need to do is we need to change our domain. Okay, we're going to manipulate it so it can generate those 4 values rather than just the 2. Okay, so what we need to do is we need to consider the solutions for -2 pi to 2 pi square bracket. Okay, so what we're going to do is that I've used a 2 and I've just simply multiplied both of them by 2 times by 2 times by 2. Okay, so what we're going to do is if we have tan 2 of x is equal to square root 3. Okay, so if we refer to a handout, we're trying to find where square root 3 is a tangent function. Okay, so the same handout that we have here. So if we go to the tan column, and we'll find that pi on 3 is actually pi on 3, so 60 degrees, so that becomes pi over 3. And that's that first value. Okay, that's still equal to 2x. Computer's a bit slow at the moment. Okay, so what we're going to do is when we do this, we need to think about the whole unit circle. Okay, so because we're now going all the way around to 2 pi, I need to consider those first two solutions. Okay, so my first one is that one there at pi on 3, and where the tan function has the same slope is the same spot on the other side of the unit circle. Okay, that will actually be 4 pi on 3, because those two angles there will be exactly the same. Okay, so that'll be pi plus pi on 3, okay, which is 4 pi on 3. So there are our first two solutions. Okay, our next two, if I draw my second unit circle, is when we're actually going the other way. Okay, so that goes to 2 pi. Okay, this second one is we're going around negative. Okay, and that's actually going to that location there at -2 pi. Okay, computer's a little bit slow at the moment. There you go. Do apologise. That goes down to -2 pi. Okay, so we're still trying to find those locations. Okay, and the slope of square root 3 is exactly the same location, okay? So it's going to be that location there and that location up there. So if I'm going from here all the way around, that location is actually negative 2 pi 3. Okay, and as we move around, that will actually be negative 5 pi on 3. Okay, so there are next two solutions. Okay, remember that same as the graph before, those angles are exactly the same, okay, because we need the exact same slope. So I'm going to write those two answers. So negative 2 pi on 3 and negative 5 pi on 3. Okay, all of this is equal to 2x. So we're going to do what we've been practicing a little bit before. We're going to divide every variable by 2. So that becomes pi on 6, 4 pi on 6, negative 2 pi on 6, and negative 5 pi on 6. Okay, what we can do, as you notice, we can simplify. Okay, so pi on 6, 4 pi on 6 is actually 2 pi on 3. Negative 2 pi on 6 is actually negative pi on 3, and negative 5 pi on 6. And what you notice is all those four values that we've generated are within our original domain of negative pi to pi. Okay, and that's what we want. So remember, we said we were planning to get those four answers. How do we manipulate it so we can generate those four values? And that's what we've got. Okay, so now we're going to move on to the last one. Okay, this is going to be very similar as we work our way through them. We're going to use different coloured pens so you know which is which. Okay, so 2 tan of 3 of x. So in this occasion, we've got the 3 of x. Okay, so over here we're multiplying every single value by 2. We're going to do something very similar. We're just going to multiply our domain by 3. Okay, so we need to consider the solutions for minus 3 pi to 3 pi. Okay, so they're the values that we're going to generate. Okay, so what we've got is it's equal to 0. So we've got I'm going to bring that 2, so that dilation of 2, that's from the x-axis. That's not going to affect any of my coordinates, okay? So if I write this formula there, so 2 tan 3x equals 0, I'm going to bring that 2 across, so this becomes tan 3 of x, and that still equals 0. Okay, so that hasn't affected it at any point in time. Okay, so what we're going to do is we're going to bring the tan across, and we're trying to find functions where tan is 0. So when tan is 0, remember tan is right up here, so tan theta, remember that is sine theta divided by cos theta. Okay, remember rise over run. So when this whole function is 0, we're actually trying to find when sine is 0. Okay, because when sine is 0, that will make that whole thing 0. Okay, so I'm going to write over here, so 3 of x is equal to, so if we refer to our little document, we're trying to find locations where inverse tan of 0 has a solution. Okay, and what you'll find is it's the same as sine, so it actually has it when sine is 0. Sine's a height, so as we start with our location there, okay, our first value is going to be the first value that we generate. Okay, but what we're going to do is I'm going to work backwards. Okay, I'm going to go back to negative 2 pi, negative 3 pi. Okay, so I've done sort of 1.5 loops clockwise. What we've got is our first value will actually be negative 3 pi. Okay, as we go back, we get negative 2 pi, negative pi, 0. I'll write the rest down here. Pi, 2 pi, and 3 pi. Okay, so those values are actually pretty easy. If we could recognise that sine was 0, we're just trying to find those locations. Okay, so it's actually pretty straightforward. What we can do, okay, remember all of this is equal to 3x, so I need to divide every single function by 3. Don't need to write, I was meant to write x. There we go, there's that. Back there. Okay, so what we're going to do is x is equal to, I'm going to divide every function by 3. So negative 3 pi divided by 3 is negative pi. I've got negative 2 pi on 3. I get negative pi on 3. I've got 0, so 0 divided by 3 is still 0. I got pi on 3, 2 pi on 3, and 3 pi and 3, which I'll cross that out, that's just pi. Okay, so what you notice is I've got quite a few values. I've actually got 7 values, okay, which is quite alright, okay, because we're just trying to find the values. We can get more than that one there. If we were to draw this function, okay, just to make sure that we were doing this correctly, what I could do is I could go to my calculator. There we go, so I bring my calculator up. If I can find my mouse. What I'm going to do is, there we go, so I'll bring this one across. Okay, so if we were to enter this function, okay, so we go 2, I'll bring my keyboard up. So 2 tan of 3x, okay, close bracket equals 0. And remember, we want to restrict the domain, okay, because the tan function will actually generate an infinite amount of solutions. We want to restrict it, okay, so get that vertical line. So given that we want, because we're dealing with negative pi to pi, so we type in negative pi less than equal to x less than equal to pi, okay. And I need to put the solve function at the front. I forgot the solve, okay. So close that, press equals. I get all these weird looking values, but if I click the standard notation button, look at these values I'm generating all these values that I've actually just calculated over there. So you can use your calculator to use this to just double check your solutions, okay. And that's those questions for the tan function, okay. So that should put you in good stead to try and attempt a few of these questions on your own. So thank you for listening and good luck.